In the previous lessons, we familiarized ourselves with many of the methods that are available on the browser's document object that relate to querying elements and creating elements. And in this lesson, I want to introduce you to the createElement method on the React object, or in other words, the React library. Now you'll notice this method shares the exact same name as the createElement method on the browser's document object. And that is by design because the React development team wants to communicate to you via the similar name that these two methods serve the exact same purpose. So what is the createElement method in the React library? Well, we can use the React library's createElement method to create what's called a React element. And that is just a JavaScript object that captures the spirit of an HTML element, but with less functionality than, say, a DOM node. So the createElement method is very comparable to the document createElement method, but it exists in the world of React, in the ecosystem of React. So we can kind of understand that these are two different methods, but I'm sure the question you have is, well, why do we need this? What's the point of having a method that basically does the exact same thing, but with React's own object and, let's say, its own fundamental infrastructure and architecture? Well, the React documentation offers us the answer. It says, unlike browser DOM elements, which means DOM nodes, the exact same ones that we were creating in the previous lessons with document createElement, React elements are plain JavaScript objects and are cheap to create. So the word cheap simply means that they require less memory and they're quicker to instantiate and create. And the reason that React objects are able to do this is because they kind of remove a lot of the fat and a lot of the extra stuff that exists on DOM node objects, which fundamentally exist because at some point they're going to be added to the visual interface, to the UI that the user sees. In React, the purpose of these React elements is actually to be maintained in something called a virtual DOM, which we'll talk about in a second. But the kind of underlying computer science mechanics of how these elements are cheaper to create doesn't really matter. We don't need to go that deep into the React code base to understand that level. The only thing you need to understand is that these React elements, which are essentially comparable or very similar to DOM element nodes, they are cheaper to create when we use React. And then what happens is the React DOM library observes the React elements that we created, and then eventually it transforms those into regular DOM nodes that we actually see in the user interface. So that process can be a little bit confusing, and in order to understand it, we need to explore something called the virtual DOM in React. So right here, what is the virtual DOM? React uses a virtual DOM under the hood, and the virtual DOM is a React-specific document object model maintained in JavaScript. So I know this can be very confusing, so let's take a step back and think about what we were doing in the last couple lessons. Imagine that we had our Chrome console opened, and I told you, forget about the entire user interface that you're seeing on the screen. Forget about that entire white box with divs and paragraphs. And let's say I asked you to build an entire web page or web application using just the methods that we talked about in the previous lessons. Could you do that? The answer is you absolutely could, right? It would be very difficult because you wouldn't be able to see anything, but obviously you can use createElement to, for example, create an HTML element and then append a child to it that would be a body element, and then append a child to that would be a div, and append a paragraph node to that div, and that can proceed all the way down through hundreds of layers. Obviously, it's very difficult, and there's no real reason to ever do that, but it goes to demonstrate the point that what we see fundamentally visually in the browser could be completely technically represented through plain DOM objects in the console in JavaScript. Right? We don't need a user interface to represent the exact same idea of a tree of elements, a parent having children, those children having children, etc., all the way down. We can go 100 levels deep and represent a web page, in theory, in JavaScript. Right? We don't need a user interface to see that. It's obviously very helpful and critical in the real world, but from a theoretical perspective, we have everything we need in the console to represent a web page without actually having the visual component. And from that point, I'd like to transition to another one and talk about the idea that whenever we're not dealing with the actual rendering of things to a user interface, a process can be a lot quicker to run. A really good analogy that I can give you here is running a program in your terminal versus running the same operation in a graphical program, right? The terminal tends to be a lot quicker. And why is that? Well, because the terminal doesn't need to worry about visual output, right? It doesn't need to give you animation or a font or worry about colors or a font size. So the terminal is just a lot more bare bones. It's just the core text analysis, right? And just running code under the hood. And that's why terminal operations can be a lot quicker than doing the exact same operation in a graphical interface or a graphical program where we need to render, obviously, visual signs to the user on what's going on. Obviously, for the user experience, the graphical interface is a lot more convenient and better and enjoyable to use, but the terminal is faster. And it's sort of the same idea when we're talking about the React's virtual DOM. Going back to that example of having an entire tree of elements in our console, imagine that we had that and only had to work with manipulating those elements and specific children without ever having to worry about immediately rendering the results on the screen. It would be a lot quicker because it's a lot easier to just iterate over children from a programmatic perspective because we don't need to waste the expensive time to render something visual on the screen, right? And then format it and then add the font size. And then add like the color, right? And the width. Those things existing as properties on a hypothetical node is much easier for JavaScript to reason about and do things with because they're just properties, right? They're not actually visual things that we can see, like a box with a width of 100 pixels with a visual background of pink. On a DOM node, they're just two properties, let's say width and color, right? It's easier to reason about, and it's easier for JavaScript to just whip through that thing and figure out what are the children, who belongs to what, because we're not worried about the actual rendering representation of that data structure on the screen. And that is the entire principle of the virtual DOM. React says, I'm going to create a basically replica of the original browser DOM, but the virtual DOM is going to exist purely in JavaScript, and we're going to have these nodes that are very similar to DOM nodes, but we're also going to cut a lot of the fat. So all these nodes really have to know is, what am I representing? Am I an H1? Okay. And what class name do I have? Okay, the class name is red text. And what children am I nesting? What are my direct descendants? Okay, I'm nesting text, right? And another React element can say, okay, I am a div, and my children are, an unordered list, and that unordered list has children of 3 list items, right? But because there's no visual component to render yet, it's a lot easier to, create these elements, remove these elements, inject these elements, etc. Because we're not worried about the visual rendered representation. We're just sticking purely with JavaScript. So that's what the virtual DOM does. It basically does the exact same thing as the browser DOM does, except it maintains all this logic, all this hierarchy, all this kind of tree structures in plain JavaScript. And then what React does is it tracks changes and it makes changes to this virtual DOM over time. And these changes are a lot easier to make and cheaper, right? Imagine, for example, that we want to exchange a class name on an element. Well, when the browser changes a class name on a DOM node, it then has to find the corresponding class that applies those styles, and then again, visually render those styles on the interface for the user to see. But if we're just looking at a class name as a basic string, then all React has to do is find that React element and change its class name from one string to another. Obviously, that operation on average is going to be a lot quicker and easier than the expensive computation of visually displaying that on the screen. So you might be wondering, okay, I'm starting to understand how React is using this virtual DOM consisting of React elements to achieve speed and efficiency. But obviously that virtual DOM is then going to get out of sync with the browser DOM because the browser is also keeping track of these things on its own terms, right, in its own ecosystem. So what React does is it observes the changes between the virtual DOM it is keeping track of and the browser DOM that exists in Chrome, for example. And then when they get out of sync, React figures out how to reconcile them in the most efficient manner. And that could simply be React saying, hey, I'm going to group and batch a bunch of changes together and write them on the screen at the same time versus, let's say, sequentially, which is how the browser does, right? The browser may say, okay, I have a class name added, so I'm going to apply that class name and force the re-render. Then I'm going to inject text, and that's going to force a re-render. React can be a little bit smarter, and it can say, okay, the user is trying to both add a new class to this paragraph and add some text in the middle. Maybe I'll combine those together in one update. So React tracks changes to the virtual DOM over time. It tracks changes to its own React elements, which again are just simpler objects representing what DOM nodes represent to the document. They're just each individual pieces of the UI, like an H1, like a div with like a P. Then React uses basic JavaScript to more quickly adjust and update the virtual DOM based on the changes that are going on. And then because that virtual DOM has gotten out of sync with the browser DOM, it compares the two of them. It figures out how to make those changes reconciled in the most efficient manner. So it says, okay, there's 5 things that have happened. I can batch 3 of them and then 2 of them, and then tell the actual DOM that these things have changed. And that's able to ensure, in general, a more efficient way of updating the browser in time. And also in managing this tree of elements, because React doesn't need to worry about re-rendering each time that one of its React elements in the virtual DOM updates. Rather, it has a more intelligent approach of tracking changes over time. And again, when we talk about over time, we're not talking about minutes. We're talking about relative to how the regular browser DOM does it. React is able to be a lot more efficient by keeping everything in basic JavaScript and then make those changes as necessary to the real DOM when they get drastically out of sync and optimized for that, all right? So in summary, a React element is very comparable to a regular DOM node that we create with the createElement method on document, but it's a lot more lighter, it's a lot more lightweight, and it's part of the larger tree of the virtual DOM that doesn't have to worry yet about visual representation all the time, which allows it to be quicker and allows it to be more efficient. The first time I heard about the virtual DOM, I thought, wait a minute, this is super expensive. Like, you have to create a whole separate copy or replica or representation of the browser's actual DOM. Like, how can this possibly be faster? It's faster because it doesn't have to worry about the visual representation of these elements just yet. Just like a terminal is faster because it doesn't have to worry about the graphical display of elements to the user. Right? Let's imagine, for example, running a process in the terminal, and then when that process is done, then updating the graphical application once after that. Right? That's basically kind of what's going on here. So the user gets the experience of speed, even though under the hood, it's using a much simpler implementation of the virtual DOM that's just concerned with JavaScript. So I know there's a lot of technical mechanics and logic going on here, but hopefully the big picture at least makes sense as to how the virtual DOM works and how it helps us achieve efficiency in the React ecosystem. That's all there is to cover in this lesson, so I will see you in the next one.